So there you have it. The Bohr atom, pictured as a dense, massive nucleus made of protons and neutrons. This comprises almost all of the mass of the atom, which is why we don't count the number of electrons when we're talking about mass. Electrons orbit at some considerable distance. Again, if we made the pen cap my nucleus, the nearest electron is a football field away. So big distances, even though they're small distances, relative big distances. Okay, so electrons will now arrange themselves in a very specific way. Okay? Once you know this, you can tell me the arrangement of all of the electrons in any atom as long as I give you the atomic number. Okay, here we go. Electrons arrange themselves in shells. These shells are labeled K through P for no good reason. K does not mean anything except for K, except for the fact that K comes before L, which comes before M. Okay, we could have labeled these shells 1, 2, 3, and 4. In fact, we do sometimes. Okay, we could have labeled them X, Y, Z, and blah blah. That doesn't matter. The point is the labeling of K does not matter. Okay, it's kind of like in an EKG when you're like, here's the P, Q, R, S, and T wave, and the P, Q, R, S, and T mean literally nothing except for that's the name of the wave. Okay, doesn't matter. All right, good. But the innermost shell is always K, so that means K equals 1. The first shell is K. Okay, that's the innermost shell, and P would be the outermost shell. Now here's the rule. 2 rules to follow. Once you know these, you'll be fine. The maximum number of electrons that can occupy a shell under any conditions follows this formula. The formula is 2 times n squared, okay? Where n is the shell number. So K would equal 1, L would be 2, M would be 3, N is 4, O is 5, P is 6. Okay, so let's do one. Let's do a practice one. Let me erase some of this, and then we'll do a practice. So as we said before, and this is the case for all atoms, okay, the K shell is number 1. I'm going to write these and then we'll turn around and talk. Okay, so N equals the shell number, K is 1, P is 6, okay? 2 times n squared, or 2n squared as they wrote up here. N is the shell number. You're going to be able to tell me now how many electrons can fit in a shell, okay? So let's pick one, 3, M shell, okay? That's the 3rd shell level up. Any atom, doesn't matter what the atom is, okay? 2 times 3 squared. Can someone help me? I forgot my order of operations. Okay, so work out what's in the parentheses. Is there any equation inside the parentheses? Just a 3, right? Then work out my exponents. 3 to the power of 2, or 3 times 3 is 9. Good. So 2 times 9, 18. Good, 2 times 9 is 18. So in the M shell of any atom, the M shell of any atom can never hold more than 18. Okay? Let's do it for the N shell. Oh. Okay, so N is 4. So how many electrons can fit in the N shell? This one. So how do we do it? 2n squared, so 2 times 4 squared. What's 4 squared? 16. 2 times 16? 32. the N shell can hold a total of 32. Let's do the O shell. The O shell is shell 5. So 5. 5 squared? 25. 25 times 2? 50. The O shell can hold up to 50. Okay? Let's do the P shell last. I think I'm beating a dead horse at this point, but that's okay. He's dead. He doesn't care. 6. What's 6 squared? 36. 36 times 2? 72. Good. 72. The P shell, at maximum, can hold 72. That's the first rule, the 2n squared rule. Here's how you're going to put it into work. Actually, let me finish the second rule, and then I'll show you how you're going to put this to work. Okay? So, the second rule. The first rule is, tell me a shell number. I'll tell you how many electrons it can hold. Not how many it is going to hold, how many it can hold. Okay? The second rule, the outermost shell will only ever hold up to 8. Okay? 8 electrons. So no matter which one of these, so let's say the O shell happens to be the outer shell. Okay? It's not going to hold up to, what did we say it was? 50? Something like that? Yeah. It's not going to hold up to 50. It's going to hold up to 8 because it's the outermost shell. So we call this the octet rule. Okay? Octet for 8. The outermost shell, we call it, the word is valence. So valence shell equals outermost shell. The outermost shell follows the octet rule. It'll only hold up to 8, never more than that. And it will always seek to get 8. Okay? Remember how I told you that those noble gases, they're full, they don't want you, right? Because they have filled outer shells. They have 8 electrons in their outer shells, except for helium. Helium's a different case, but the other ones have 8 electrons in their outer shells. They're full, okay? They don't need to interact with anything because their valence shell is completed, okay? Once your valence shell is complete, as an atom, you're not going to seek to bond with any other atoms. All of chemistry is the bonding of valence shell electrons. You guys probably heard of the phrase covalent bond in high school, right? Remember that from math or science class, right? That's valence shell electrons bonding with each other. Okay? Covalent bond, okay? Valence shell's the outer shell. The valence shell always follows the octet rule, okay? So in a minute here, a light bulb's about to go on because you go, well, now I know why hydrogen bonds with oxygen to make water, okay? And everything else on top of that. So let's use this and let's figure out some things, okay? So, all right, so let's take oxygen, which oxygen has a Z number of 8, okay? Let's draw oxygen, all right? So it starts with just making, a little circle to represent the nucleus, okay? And you make 8 positive charges. Somebody go run over there and tell me what oxygen's atomic mass is.
Oxygen's atomic?
Yeah, not the number, but the atomic mass. It'll give you the average atomic mass. Top
15.
left. 15? Good. So 6, 7, 8. 15 minus 8? 7. Good. So that'll be 1, 2, 3, 4, 5, 6, 7 neutrons. A little complicated, but in this nucleus there are 8 positive charges, oxygen, and 7 neutrons. Ignore the neutrons, okay? Let's use the octet rule. First off, how many total electrons should oxygen be holding on to? 8, right? So oxygen, we'll say, should hold 8 electrons total, okay? That would be neutral. That would be neutral oxygen, okay? Let's draw this then. We're going to have a first shell, right? We have at least 1 electron to hold on to, so we'll have at least 1 shell. How many electrons are going to be in that K shell? Somebody work out that 2n squared formula for me. How'd you come up with that? Because 1 squared is 1. 2 times 1 is 2, right? So this first shell is going to hold 2 electrons. Yeah? That's first shell full, okay? How many more electrons do we need to grab onto? 6 more, right? So we need to add another shell. Oxygen requires an L shell. How many? Someone do it for us. What's the 2n squared rule for shell 2, the L shell? So 2n squared, 2 times 2 squared. What's the answer to that? You agree? So 2 squared is 4, right? 4 times 2 is 8, okay? So we have a second shell that we're going to need to occupy. We can hold up to 8 in that shell, okay? Because the 2n squared rule says we can, okay? All right, so but do we have 8? Are we going to need 8? No. We're only going to need 6, right? So here's how it's going to go. You're going to have a second shell, okay, further away than the inner shell, and you're going to have, they'll pair themselves up, but 1, 2, 3, 4, sorry, 5 and 6, okay? Now you have an electrically neutral oxygen atom, okay? You should count 8 electrons in orbit because of the 8 positive charges in the nucleus. However, there's a second rule. What is that second rule telling us?
It overrides the other.
Right. So although oxygen is electrically neutral, it's not going to be chemically neutral. Does that make sense? It's electrically neutral because positive and negative charges are balanced, right? It's happy, but it's only electrically happy. Chemically, the octet rule tells us that this outer shell is incomplete, okay? This oxygen atom is now going to seek to make a bond with any other atoms that it can so that it can borrow 2 more electrons for its outer shell, okay? It will be negatively charged when it does that, so it won't be electrically neutral anymore, but oxygen is not happy when it's electrically neutral. Oxygen is only happy when it's chemically neutral. Does that make sense? Okay, good. So, any way that we can give oxygen 2 more electrons to hold on to, we will be completing the octet rule and we'll be able to make a chemical bond with oxygen. So let's briefly talk about another kind of atom. I think some of you probably are getting where I'm going with this, but let's just keep walking this through. Alright. So let's take another one. Let's talk about hydrogen. By the way, I could do this with just 2 oxygen molecules because O2 is a thing that happens. But anyways, let's talk about hydrogen. What's the atomic number for hydrogen?
Hydrogen is 1.
Simplest element is just going to be 1. And I'm going to walk over here to remind myself what the average atomic mass is, because it's just 1. Yay.
1.00. Cheating.
Feel stupid when I do that. You guys have probably heard of tritium, right?
Mm-hmm.
Yeah? Or deuterium? Mm-hmm. Yeah? These are just isotopes of hydrogen. Okay? They're just hydrogen plus some neutrons. Okay? If you look over here, the atomic mass, well, the atomic number of hydrogen is 1. But look at the atomic mass. It's hard to see, but it's also 1. Okay? That means that hydrogen doesn't hang on to neutrons typically. Okay? When it does, it becomes other things. Okay? Some of those things glow in the dark, like tritium. Okay, good. Hydrogen has an atomic number of 1. So let's draw hydrogen. Hydrogen's got a positive charge in the nucleus. That's it. That's its nucleus, just 1 proton. Okay? Let's use the let's use the 2n squared rule. Let's real quickly figure out how many total electrons will hydrogen hang on to? Can it hang on to on its own? 1. How do you know that? The atomic number is 1, right? Boom, good. But use the 2n squared rule. Tell me how many electrons can fit in the innermost shell. 2, right? The 2n squared rule tells you the K shell will hold up to 2, okay? So you draw this, and you show me that there's hydrogen, its inner shell is also its outer shell, okay? And its inner shell only will hold one. Its valence shell is also, it's a sort of weird one because its valence shell is also its K shell, but importantly, it's only going to want to hold one. This atom is electrically neutral now, okay?
Does it have a proton or neutron?
No neutrons,
Okay.
unless it's an isotope like deuterium or tritium, but no neutrons right now. Chemically happy, stable hydrogen has one proton, nothing else, and an electron, of course. So again, this guy is kind of like that guy. This is electrically neutral, but not chemically neutral, okay? How many more electrons is this going to try to hold on to fill the inner shell?
7.
It was 7, yes, but first 1 to fill the inner shell, okay? So this guy needs 2 to fill its inner shell, or excuse me, the outer shell. This guy needs 1 more, okay? So what if I just had 2 of these, okay? Well, then you do that. You take and I'm going to redraw some of this. Let's do it over here. There's hydrogen's nucleus. There's hydrogen's 1 electron. Okay. Let me see if I can move these electrons around. Okay. Boom, 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 boom. We got all the numbers we want. Okay, good. So when you have 2 hydrogen atoms and 1 oxygen atom and they come in contact with each other, remember, they're not chemically neutral. They will react with each other, okay? When they do that, each hydrogen atom will borrow 1 electron from oxygen, completing its inner shell. That's done. Hydrogen will borrow 1 electron each oxygen will borrow 1 electron each from hydrogen, completing its outer shell for the octet rule. Both of these are now chemically neutral, okay? Chemically neutral, to an extent. They have hydrogen completed its inner shell, oxygen has completed its outer shell, and they're happy. They're sharing electrons now, okay? They are forming these bonds, hydrogen bonds, sharing electrons, okay? Both of these things are pretty happy now. The only one caveat is with this one, water, it's not electrically neutral, okay? By themselves, they were electrically neutral, but not chemically neutral. When you bring them together, they're more chemically neutral, but now they're not electrically neutral, okay? There is an overall positive charge on this side of it's now a molecule, right? We put 3 atoms together. There's an overall positive charge over here because the electrons for hydrogen are all on this side of the electron, or on this side of the hydrogen atom, okay? There's no electrons over here to balance out the overall charge, okay? So this side of the molecule is overall positively charged, and that side of the molecule is overall negatively charged. Water has polarity. That's why water can exist as a nice little liquid here on Earth, because these molecules of water sort of slip and slide past each other because of this polarity, because of this difference in charge from one end to the next. It's beyond really what I was trying to show. What I'm just trying to show is that electrons will arrange themselves in a specific way because of these 2 rules. The 2n² rule tells you how to get all the way out to the outer shell. Once you're at the outer shell, however many electrons less than 8 are in the outer shell are how many electrons that atom is going to try to grab onto to make a chemical bond. It will only bond with other atoms that can donate that many electrons, or combinations of atoms that can donate the right amount of electrons to share and become more chemically stable. Okay, yes?
Alright, so is that why water can conduct electricity?
Yeah, part of why, yeah. Yeah. Let's call it for today. We got more to talk about, but we'll add it on the next class. So we made it all the way up to talking about the structure of atoms and the arrangement of atoms in the nucleus. I would